Computer programming involves composing sequences of instructions, known as programs, that guide computers in performing tasks. This creation process includes designing and implementing algorithms, which are step-by-step procedures specified by writing code in programming languages. Tasks that accompany programming include analyzing requirements, testing, debugging, implementing build systems, and managing resultant artifacts like machine code. While these tasks are part of the programming process, the broader term software development is often used to encompass all stages, with programming, implementation, and coding, specifically referring to code writing and editing. Software development is sometimes termed software engineering, particularly when formal methods or an engineering design approach is applied. Early instances include a 9th-century programmable music sequencer developed by the Persian Banu Musa brothers and a 1206 programmable drum machine created by the Arab engineer Al-Jazari. The Jacquard loom in 1801 showcased programmability by changing weaving patterns through a series of punched cards. Code-breaking algorithms have also featured prominently in history, with Al-Kindi describing cryptographic methods in the 9th century. The first computer program is attributed to Ada Lovelace in 1843, who designed an algorithm for Charles Babbage's analytical engine. Lovelace's work extended beyond math calculations, envisioning broader applications for the analytical engine. Data and instructions were initially stored on punched cards before Herman Hollerith introduced machine-readable data storage in the 1880s. The concept of the stored program computer revolutionized programming in 1949, allowing data and programs to be manipulated in computer memory. Machine code was the initial language used, written in the specific machine's instruction set. Assembly languages provided a textual format for programming, offering meaningful operation code abbreviations and address specifications. The development of high-level languages like Fortran in 1957 simplified programming, making it more comprehensible and less tied to hardware. Grace Hopper's A0 system in 1952 marked the beginning of compiler-related tools, enhancing the programming process. Compiled languages enabled programmers to write code in a syntactically richer manner, abstracting complexity and facilitating compatibility with different machine instruction sets. Source code entry evolved from punched cards and paper tape to direct typing on computers in the late 1960s, aided by cost-effective data storage devices and computer terminals, along with text editors for easier corrections. The final program must satisfy critical properties, including reliability, robustness, usability, portability, maintainability, efficiency, and performance. Reliability is about the correctness of program results, depending on algorithms and minimizing errors like buffer overflows. Robustness involves anticipating and handling issues due to errors, like incorrect data or power outages. Usability refers to how easily a program can be used, affecting its success. Portability concerns the platforms on which the program can run. Maintainability is the ease of modifying a program for improvements or bug fixes. Performance is measured by system resource consumption. Efficiency in resource usage is crucial, including managing resources like memory and cleaning up temporary files. Readability of source code is vital, impacting portability, usability, and maintainability. Programmers spend much time reading and modifying code. Different factors like comments and naming conventions affect readability. Algorithmic complexity involves finding efficient algorithms using Big O notation. Development processes typically start with requirements analysis, testing, and value modeling, then move to implementation and debugging. Programming languages support various programming styles from low-level to high-level languages.